Which homologous series is that among the three? Huh? It must have another C there. Yes.
I think it's the last one.
Which one? Alkyne. Eh? Why are you saying alkyne? Guys, when you find this and you can't know it exactly, expand it. And then CH, because this one is CH3. You have there. Now, a bond goes here, isn't it? But here I don't have hydrogen. You see? Even the next, I don't have hydrogen. And then the last one I have CH and then 3 hydrogens. Are you seeing? If I have no hydrogen here, what does it mean? It means that I have to make sure that there are 4 bonds. So I have, for this one is 1, 2. So I have to add another one. 1, 2, 3, not yet 4. I have to add another one. 1, 2, 3, 4. So 1, 2, 3, 4. You see? Now it means that the structure looks like this. Now you ask yourself, the one which has a triple bond is an alkyne. Why am I doing this? Is because of the, sorry? Good morning, ma'am. I'm okay. So what I was saying, last time they brought this question, and I saw that many people failed this question. If the question is like this, CH3, ne? CH2, ne? CH2, 2, ne? CH3. What does it mean if it's like that? Remember, in most cases we said that when something is in the brackets, it means a branch. But it depends on whether it's a when does it become a branch. If you look at this, is this a branch? If you expand it to be like this, the structure formula, you'll find out that this is not a branch due to the number of carbon atoms and the number of hydrogens attached. Let's expand it and we find out if it is a branch. CH3. CH3, isn't it? CH2. This one is there too, isn't it? Now, this here, it is having already 2 carbons. Sorry, 2 hydrogens. And one hydrogen, another bond is gonna be joining another carbon. You understand? So you have 1, 2, 3, 4. So it can't be a branch. If it was a branch here, this would have been 1 carbon. So that now another carbon atom is down. But now because there are two hydrogens, therefore it can't be a branch because already the carbon atom has taken all the 4 bonds. It cannot have more than 4. Therefore the first bond is going to be joining this carbon, which is again CH2. But they are saying that this carbon is times 2. I think. So it's going to become again CH2. So it means that now I've written this. It was just compressed a bit. And then now it's going to have CH3, which is hydrogen. Are you seeing? When does it become a side branch? A side group or a side molecule? Let me give you the same example. Yes. If it's like this, it's not a branch. It's not a branch. Why? Because if you try to expand it, it won't have a room for the carbon atom to what? To expand. To expand on it. It won't have that room for the carbon atom to do what? To attach itself. Because the carbon atom is already having 4 carbon 4 bonds already is full. It cannot have more than 4 bonds. Now let's look at another example, and then we see when does it become a branch.
So you said the first one is not a branch because it has 2 hydrocarbons there by the CH2.
Yes, because now if I put here the 2 hydrogen atoms, ne? It will have 1, 2, 3, 4 bonds. Now where is the branch gonna go? So it is just an extension. Now look at this. Look at this. It's the same thing, but I've reduced the number of carbon atoms. Sorry, the number of hydrogen atoms. Now let's write it in the structure formula. CH3, I see. Now let's go to this. C, it's only having 1 hydrogen. I see. But another bond must be linked to another carbon atom. We're going to find out whether it's this or this. This one, the next one, it has 3 of them. Therefore, if it was 2, then it would have been a double bond. But because there are 3, it means that if I put the 3 here, this carbon atom is going to be full. There is no way how I can put a double bond there. I think. Therefore, it means that this is a branch. Therefore, this one, you see that there is a room for another bond. So that bond is going to be for this which is in the brackets, whereby I'm going to have that, the first carbon atom, but they say that it is times 2. This one has 2 hydrogen, but they say that times 2. Ne? Okay. There is something which is missing here. Ne? There is something which is missing here. Okay. Let me just say, let me just use that. So it means that, look, it means that now this is a branch of this. I think. So it means that now I have 1, 2, 3, 4. Done. 1, 2, 3, 4. I think. Done. 1, 2, 3, 4. Done. Now this one, because it's in the brackets, you said that if it is in the brackets, it will only be a side group if you see that the number of hydrogens, they are missing. There is at least one hydrogen. If it is 1, you see that there is 1 hydrogen which is missing on this. And if you try to put a double bond, the next carbon atom is already full. Therefore, it means that that becomes a what? A side group. Are we together? Yeah, please. They brought this question in the previous paper, and most of the kids, they did not find it correct, because they thought that whatever it is in the brackets, it is a branch. But it's only a branch if the number of hydrogen are less. Then it becomes a side group. Any question there? Yes. Where? Oh, the first example. If now I have a 2, now it depends. Ne? For example, if I have a 2 here, ne? You mean this one? If I have a 2 here, I have a 2 outside the bracket. Now, so now if it is, no, the 2 inside, it was a small mistake. Ne? It was just a small mistake. Why? Because the number of carbon atom, each carbon atom is supposed to have 4. So it was short with the 1 carbon. Ne? You understand? Mm. No. No. Why? He's saying that what if it is like this and 1 hydrogen is absent here, 1 carbon atom to be a part of main chain, and then another to become the side group. Remember that the side group, the second one will also have two hydrogen instead of 3. therefore it will be short with one hydrogen. So it means that it can't be unless it is within the main chain, but the moment is a side group. If it is like this, then it means that the number of carbon atoms here are going to reduce. So that now, it's like this now. It means that now I have one carbon here, and I have another side group this side. Are you seeing? So that when you count 1, 2, 3, 4. So one CH3 is here, and another CH3 is that side. Is it clear? Yes. So the number of hydrogen, they are a very important factor to determine the kind of structure you're gonna write. That's why we are saying that if you write a structure and this structure does not have maximum number of hydrogen, then it means that that structure is not correct. Is it clear? Let's continue. So I think naming these organic structures, you are fine. Let me just write one structure here, and you label it for me, and then also write another structure, a name, and then you draw it for me. Then once I see that you have got it, then we continue.
These examples that
Yes. Yes. Sorry?
are they all
Oh, she's asking which homologous series do they belong? Because this is a single bond throughout, it's going to be alkane. Even this one is single bond throughout, it's going to be alkane. Isn't it? Okay, since we wrote this one is simple.
So that
Let's,
first one, C8 is alkyne.
this one is alkyne because it has a triple bond in between. Let's just label this instead of writing another structure. Let's label this. Who can label this for me? The name. IPAC name.
Or like 1, 2, 3, propene.
Where's the main chain? 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So everything is 1, 2, 3. So you just have to choose. So if we make this one a main chain, 1, 2, 3. So it's gonna be? 1, 2, 3 is what? Prop. But it is an alkane. So it's gonna become propane. Ne? Alright? And then the side group is we have on number 2 and also have on number 2. Isn't it? So it's gonna be, what is the side group? Is it ethyl, methyl, propyl? What is it? Methyl. Why are you saying it's methyl? 1. Because meth means what? Means 1. Meth means what? 1. So it's going to become meth. But when you add YL, it means a side group. So it becomes methyl. But this is on which carbon atom? It's 1, 2. So it is on carbon atom number 2. Is it clear? The first methyl is carbon atom number 2. The second methyl is on carbon atom number what? Number 2. So it's going to become 2, 2. Because there are 2 methyl, 2 is di. Ne? So it becomes, remember, a figure and a figure, we separate it with a dash. A figure and a letter, we separate with, a figure and a figure, we separate with a comma. And then a figure and a letter, we separate with what? A dash. So it's going to become 2, 2 dash di methyl propane. Is it clear? 2 di methyl propane. So now they can bring this name and ask you to draw the structure. Yes. Still, it is simple. It is simple. How is it simple? I told you that when they bring such and you want to draw a structure, we are just doing this to remind you and to minimize the time of you revising. Yeah, that's all we're supposed to do. Ne? Now, if they bring this, ne, you start with the main chain. Is it clear? You write it. They are saying propane. when you say propane, it means that there is no double bond, there is no triple bond anywhere. So it's going to be prop is 3, isn't it? So 1, 2, 3. That's the first step when you are writing it. They say that you have the first side group on carbon atom number 2 and the second side group on carbon atom number 2. So it means that this is a side group and this is a side group. Is it clear? So which side group? We have a methyl. A methyl has 1 carbon atom. And also another methyl has also 1 carbon atom. What is left? We have talked about this. We have talked about this. We have talked about this. Now the rest is bond, and you put the bonds and the hydrogens. Done. Remember that each carbon atom is supposed to have 4 what? 4 bonds. Therefore, I'm gonna do hydrogen, hydrogen. Don't miss out, ne? Because if you miss out the mark. The structure is done. We are back from where we came from. So, as simple as that. Come here. Any question? All right. I think that's alkane, alkene, and alkynes. Just I want to ask you one question. This kind of homologous series, it belongs to these 3 homologous series. They belong to a group of molecules called hydrocarbons. What are hydrocarbons? What are hydrocarbons? These are molecules which are made up of carbon and hydrogen only. They're saying hydro from hydrogen, hydrocarbons. It means that it is made up of hydrogen and carbons only. Only. You want to see that word only? Ne? It's made up of hydrogen and the carbons only. Another thing, before we shift from this. When you do combustion, you know combustion? What does it mean? Burn. When you burn it in air, yes? In the presence of oxygen, you always produce 2 products. You always produce 2 products. Is it clear? What are those 2 products? What are those 2 products? When you burn hydrocarbons, hydrogen and the carbon, how do you, what are those 2 products? Huh? Carbon dioxide and what? And carbon monoxide. Okay, thank you. Tokero? H2O. H2O and carbon dioxide. Guys, those are the only products you produce. Okay, you produce heat, but we don't include the heat in the equation. We can say delta H, and then it's an exothermic reaction. Yes? But whether you burn alkane, whatever molecule, whether you burn alkene, whatever molecule, you burn alkyne, whatever molecule, the product is 1. Water plus carbon dioxide. Nothing else. So when they say, they bring it, you have burnt combustion of hydrocarbon. Guys, don't think. The answer is 1. You don't need to think. Product is water plus carbon dioxide. That's 1 mark you have got. The second mark is going to be on balancing. Now the balancing is going to, for these ones, sometimes they disturb. You understand? But if you see that the balancing is a problem, leave it. Go to another question, put a star there, go to another question, finish other questions, you come back. Don't sleep in exam. Please, Litabo, don't sleep. You are sleeping on your marks. You understand? So, after that, you come back, and then you do what? You do the balancing. Sister, is it together? Are we together? Are we done with this now? Now, it means that now these molecules, at least if they bring any question, you're gonna kill it. Isn't it? Okay. One last question. Yes. One last question. Now it means that now we are phrasing, we are combining all of them. Remind me, what are isomers? What are isomers? What are isomers? And you're gonna tell me the different types of isomers with examples. You can't go to exam without knowing isomers. Impossible. What are isomers? What are isomers? It doesn't. It's somewhere there. We want it in your head, not somewhere there. Yes.
It says many compounds that have the same molecular formula but different structural formula.
Molecules with the same?
Yeah, that have the same molecular formula
Same molecular formula,
but different structural.
but different structural formula. We call them isomers. Ne? Okay. Same molecular formula, but different. Look at this. CH3, CH2, CH2, ne? CH2, CH3, ne? Are you seeing it? Now, what I'm gonna do? 1, 2, 3, 4, 5. Ne? 1, 2, 3, 4, 5. How many carbon atoms are there? 5. C, 5. 2, 3 plus 2? 5 plus 2? Plus 2? Plus 2? Plus 3? 12. Structure. This is the molecular formula. Isn't it? This is the molecular formula. Then they ask you, write down different isomers of this. So what do you do? What do you do? Remember, when you go back to your formula, how do you know that this is alkane, this is alkene, this is alkyne? When you go back to your formula, general formula, you'll find out that if you say C is 5, ne? H is supposed to be 2 times the figure which is here, which is 5, ne? Plus 2. Are you seeing? So it's gonna be 5 is fine. This one is gonna be 10 plus 2. Plus 2, which gives me 12. It means that the hydrogens are 12. Don't you see that? So if it diverts, it means that that's not alkane. But now because this obeys this, then it means that this is an alkane. So it means that when you are drawing the structure formula, there is no double bond, triple bond anywhere.
So, sir, with isomers, it depends on the formula that they give us.
Yeah, alkene, alcohols, carboxylic acids, it can be anything. You understand? But I'm just bringing it here so that when we reach there now, it's a little bit simpler for us. Ne? Okay, now, if they write it like this, this is the condensed structure. Ne? But how do we change this to become an isomer? Create a side group. You understand? How do I create a side group? Make sure the number of hydrogens, they don't change, and the number of carbons, they don't change. For example, 1, 2, 3, 4, 5. What if I say 1, 2, 3, 4? I put the 5 there. Put hydrogens. If we count the hydrogens here, there are 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I see. How many carbons? 1, 2, 3, 4, 5. You see? This is an isomer of that. What about, I put say 1, 2, 3, ne? 4, 5. When you count them, we'll find out that it is 12 hydrogen. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What is missing? Where is it? Yeah, here. 12. I skipped it. So there are 12.
So you don't count the bonds.
No, we are counting only where hydrogen goes. You understand? I'm only counting where hydrogen goes. Because the hydrogen can't go here. It's already carbon. So you see that the hydrogen are 12 now. If you count the carbons, 1, 2, 3, 4, 5. Still is 5. So this is an isomer of this. Still this is an isomer of this. Because this is straight chain, but this is branched chain. I think. So that's how you write these isomers. They can ask you, give you one molecule, and then ask you to write the isomer. In most cases, this is a chain isomer. It's the same molecular formula, but the chain is changing. The substituents are changing. The position, the side group, they have a side group. The position of the side group is what? Is changing on the what? On the chain. You understand? Remind me the different types of isomers. Chain isomer, functional isomer, positional isomer. Then remind me the definition for each.
Some functional different, same molecular formula but different functional group, and then the chain.
Different functional group.
They all have
Same molecular formula.
but you just change the different functions.
I gave you a simple definition, a simple way how you remember. They start with the same definition, same molecular formula. But if it is a functional isomer, then the function is going to be what? Be changing. You understand? Positional isomer, same molecular formula, but different position. You understand? Yes. So that's how you're supposed to define it. But the problem will come with the examples. Functional isomer, different functional groups. What does it mean? For example, same molecular formula. This will apply with the esters and the carboxylic acid. They have the same molecular formula. But what changes is the functional group. The other one is having the functional group as an ester, while the other one has the functional group as a what? A carboxylic acid. Is it clear? People are forgetting. People are what? People are forgetting. All right, let's look at it. Ne? Let's look at it. Guys, you can't go to the exam without knowing these simple things. You understand? You can't. There is no way you can go to the exam without knowing these simple things. All right. Let's look at it. Let's give an example of a carboxylic acid. Ne? A carboxylic acid. A carboxylic acid, remember, it has its functional group at the end. We don't have to mention the position of the functional group on the carboxylic acid. We cannot mention the position of the functional group on aldehydes. You understand? So, for example, 1 CH3 CH2 COO. That's the carboxylic acid. This carboxylic acid is what? 1, 2, 3. So it's going to become propanoic acid. Is it clear? Yes, it's propanoic. 1, 2, 3. It's going to become propanoic acid. Now, if I want to make it an ester, I have to put this in the middle. But you'll find out that it has the same number of carbon, same number of hydrogen. Therefore, it becomes a functional isomer. You understand? For example, let's do it. CH3 C. Yeah, I'm writing now ester. Yes. I'm making it an ester. Now it is an ester. Let's count the number of hydrogen. And then we see if we put the bonds, they're gonna fit when we expand it. 1, 2, 3. Carbons 3. 1, 2, 3. Done. Hydrogen 6. 3, 6. I think This is a carboxylic acid. This is an ester. But are you sure that the number of bonds are fitting on these structures? Let's see it. CH3, remember each carbon is supposed to have how many bonds? 4. If you exceed 4 or less than 4, 0. CH3, these are 3, ne? This is 2, ne? Then carbon, this oxygen. How is this oxygen? It has a double bond there, and then it has that there. So that this carbon, this is like that. You understand? And then this oxygen is here. I think. Therefore, it's going to be 1, 2, 3. I see. So it is 1, 2, 3, 1, 2, 3, 4. Done. 1, 2, 3, 4. Done. 1, 2, 3, 4. Done. Oxygen is supposed to have 2. 1, 2. Done. So it means that it fits. What about this? Hey, now the problem is here. Let's look at it. C is CH3, isn't it? What about here? C, double bond, oxygen, and then, O. Now this is not hydrogen now. It is a carbon. Are you seeing? But this carbon has 3. Are you seeing? Done. 1, 2, 3, 4. Done. 1, 2, done. 1, 2, 3, 4. Done. 1, 2, 3, 4. Done. So this is a carboxylic acid, while this one is an ester. What is the difference? Here the functional group is at the end. Here the functional group is along the chain. Is it clear? Yes. If you write the molecular formula, it's the same. So the same molecular formula, but different functional groups. You understand? Different what? Functional groups. Yes.
That you said whereby the functional group has to be either in the middle or at the end.
Yes. When it may not be actually middle, but it must be along the molecule. It must not be at the end. Then it's going to become an ester. It must not be in the middle at all. It must be at the end or at the beginning. I don't know whether it's the end or what is the beginning. When you say this is your beginning, it's fine. Because you can also swap it and then it starts from this side. It still is fine. You understand? Yes. So if it is at the end, it is carboxylic acid. If it is along the molecule, it is an ester. The same thing, carbonyl compound work. Remember carbonyl compounds? We have ketones and aldehydes. If it is in the middle, can I rub off? If it is in the middle, then it becomes keton. If it is on the side, it becomes aldehyde. For example, CH3C CH3. Let me put the O there. Ne? CH3C H2C. This is an aldehyde. This is a keton. If we try to expand it, we shall see that the number of carbons are, all of them, they have 4 bonds. But this one only has 1 oxygen. Let's look at it. CH3, double bond. That is a keton. I see. Well, this one, CH, no, man. I see. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. You see? So this one is a ketone. This one is an aldehyde. So it's also another example of functional isomer. There is also another functional isomer, but we don't study it. That is alcohol and ethers. We don't study ethers, but we study alcohols. So we can't talk about ethers because we don't study ethers. But it's also another functional isomer. Is it clear? I think I've exhausted that part. Let's go now to alcohols in detail. Let's look at what? Alcohols.
So
If you have any question before we go, please you ask. Ne?
we're not going to do examples of positional and isomers.
Huh?
We're not going to do examples of positional isomers.
She's asking me, are we not going to do examples of positional isomers? And what? Chain isomer, we saw them on alkanes. Yes. But positional isomer, still, we can talk about it when you go to alcohols. Remember, alcohols, they are grouped into 3 classes. The first class is primary alcohol. The second class is secondary alcohol. The third class is tertiary alcohol. Is it clear? Okay. You remind me to talk about the positional isomer. Yeah. How do you write the general formula for alcohols? C N H2N plus 1 OH. Yes. Now, instead of saying plus 2, the hydrogen is being replaced by OH. Is it clear? Yes. Actually, alcohols, they are a little bit the same as alkanes. The only difference is, because also these ones are single bonds throughout. The only difference which is there is the OH here, while in alkanes, there is no OH. Is it clear? Yes. By the way, I forgot to talk about that alkynes, sometimes we call them paraffins. Ne? Yes, when you talk about paraffins, we are talking about that homologous series. Ne? Yes, those are the paraffins we use. We said that we have the primary alcohol. Primary alcohol, this is the type of alcohol whereby we can define it into 2 ways. Ne? Either in terms of hydrogen on the carbon atom with the functional group, yes, or carbon atoms attached to the carbon atom with the functional group. How many hydrogens are attached to the carbon atom with the functional group, or how many carbon atoms are attached on the carbon atom with the functional group? Okay, let me give you example here, and then you will see what I'm talking about, so that you remember. Ne? Let me say I have a primary alcohol, and this primary alcohol, CH3, CH2, CH2. Ne? I'm going to use the same molecule to find out which one is the primary alcohol, which one is the secondary alcohol. CH2OH. Is it clear? Is it clear? That's the primary alcohol. Secondary alcohol, CH3, CH2. Ne? Should I use that technique of the brackets, or I should expand it? Bracket. CH, CH. Let me say CH, CH. 3. Let me just say, no, on 3. 3 there. CH3. CH2OH.
So the first one is a primary.
Oh, with the carbon atom. This is now I don't know whether you see it. Let me write it. CH3. No, I want to make it clear for you. Ne? I want to make it clear for you. 1, 2, 3. Ne? 1, 2, 3, 4. CH3. That's a secondary alcohol. Are you seeing? Eh? Now, I'm going to expand it so that you see it clearly. Ne? Then the third one is going to be CH3, ne? C, ne? Ne?
So they're all primary alcohol.
No, man. One is a primary, one is a secondary, one is a tertiary.
The other one is the second. The second one is a secondary.
Ah, this is primary, this is secondary, this is tertiary. Now, let me draw it there. I expand it so that you see it clearly. Ne? Why am I saying primary, secondary, and tertiary? We can bring it like this. Ne? So, when I'm writing, this one is simple. Everything is fine. Ne? The OH is at the end. But here, this is where I want. You understand? Okay, let me expand it. CH. Like that. I'm only going to write, okay? Let me write them so that you don't say that I didn't write them. You know, when you write something, even students, they will write it in exam. If it is a little bit, you want to do it a shortcut, they will do the same thing in exam. They will do the shortcut. Okay, this one is, look guys. This one is C. It has one hydrogen, I think. It has the OH, I think. Yes. And it has this. 1, 2. Did I?
So that's the H.
No. It's supposed to be 2, ne? It's supposed to be 2 there. I'm coming, ne? CH. You're so confused, ne? I'm coming. And then this one, how many carbon atoms? 1, 2, 3, 4. 1, 2, 3, 4. Yeah. Then 1, 2, 3, 4. Okay? C. Even this one is supposed to be 2, no? It's 1. Yes, it's 1. No, it's fine. Alright. CH. The first one is, I'm going to explain, so that you get it clear. CH2. This one is having OH. I see. So it has, okay, let me, it's 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. It's fine. Let me do it like that. I've added more than what is needed. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I'd use the 5. Ne? So it's gonna be CH. It has a side group. It has a side group there. CH. Okay. Those are the 3. This is primary, this is secondary, this is tertiary. Ne? Primary alcohol, the carbon atom with the functional group, it has 2 hydrogens. You remember? Sandile. Primary alcohol, carbon atom, This is the type of alkyl or class of alkyl whereby the carbon atom with the functional group, with OH group, has 2 hydrogens, I think. Or you can define it in terms of carbon atoms. This is a class of alkyl whereby the carbon atom, this carbon atom with this OH group, is attached to one alkyl group. One alkyl group. One carbon atom. You see, it's only one carbon atom attached. Alkyl. Alkyl. This. Because we don't know how many carbon atoms are there. Ne? No, alkyl. Alkyl. A side group. We call it alkyl group, which is an alkane, which is the only carbon, hydrogen and carbon. And then now, when you come here, check the carbon atom with the functional group is this. I think. How many hydrogens are attached on this carbon atom? Check. How many hydrogens? So it's the type of, is a class of alkyl whereby the carbon atom with the functional group is attached to one hydrogen. While this one, check. The carbon atom with the OH group or the functional group it has no hydrogen. I think. So primary has 2 hydrogens. Yes. Secondary has 1 hydrogen and tertiary has no hydrogen. But don't say is alcohol whereby it has no hydrogen. Where? You have to specify that the is a class of alcohol whereby the carbon atom with the functional group or the carbon atom with the OH group is attached to 2 hydrogen atoms. Is it clear? Then here is a class of alcohol whereby the carbon atom with the functional group is attached to 1 hydrogen atom. And then here is the type is a class of alcohol whereby the carbon atom with the functional group or with OH group is attached to no hydrogen atom. Yes. Number 3. This side.
I see 4 carbons.
4 carbons. 1, 2, 3, 4. Yes. The what?
5 carbons.
How? 1, 2, 3, 4. Oh, then it means that one must be go. This one in the middle. Yeah, let me just rub off this and then I just put a hydrogen. Sorry, ne? Maybe just need to count it properly. So now, guys, come back here. What I told you at the beginning about the side group. This is not a side group. Well, this is a side group.
Sir?
This is not a side group. Well, this is a side group. This is not a side group. It's just condensed. But this is a side group. You see? Here, I don't have a side group here. But here I have a side group. Yes, because of this, it shows it's a side group. But because of this, it means that this one, if it has two hydrogens, it means that it has 2 extensions. But if it has 3 hydrogens, it only has 1 extension because it's supposed to be with the 4. So it means that it is attached here. While this one is just an extension. So this one, I can also write it in another way. How? How do I write it? I can just do this, and I just say CH2, CH3. It's the same thing. You understand? It's the same thing. Yes. So, it's just sometimes we just write this to confuse you or just to condense or to see that you guys, you understood. Remember, science is not about cramming. You have to understand the concept. And once you know the concept, then you'll be able to know. Now, sister, you talked about the position isomer. You talked about what? Position isomer. Same structure formula, but different position of the what? Of the functional group. Is it clear? This and this are positional isomers. This and this are positional isomer. While this and this, they are structure isomer. I think this and this are positional isomer. While this and this are structure isomer. Chain isomer, it's the same thing. Structure isomer, chain isomer is the same thing. Ne? How? I was expecting you to tell me, to ask me how. How comes here. Positional isomer. The functional group, the position of the functional group is changed. Same structure formula, but different position of the functional group. When we count here, we see that 1, 2, 3, 4, or 1, 2, 3, 4. Here, when we count from this side to this side, it's going to be on carbon atom number 4. While this side is going to be on carbon atom number 1. Is it clear? So we take the position in number 1 because it's less than 4. Is it clear? So here, the OH, I'm going to say 1 ol, isn't it? But yes, 1 ol. Propan 1 ol. For example, butane 1 ol. So which 1 means the position. While here, 1, 2, 3, 4. So here it is on carbon atom number 2. While this one, 1, 2, 3. This is 3. So because 2 is less than 3, then we're going to say 2. So this one is going to be 2 ol. While this one is going to be 1 ol. You see that the position of OH is different. Yeah. Are you seeing? So changing, note on this. Changing primary alcohol into secondary alcohol, it makes positional isomer. Primary alcohol, secondary alcohol. Definitely is going to become a positional isomer. If you're given a primary alcohol and they want you to write an isomer, a positional isomer, definitely you just change it from primary alcohol to secondary alcohol. Definitely it changes the position of the what? Of the functional group. Is it clear? Now I said this and this, they are chain isomers or structure isomers. Why am I saying that? Here, 1, 2, 3, 4. So this one is on carbon atom number what? 1, 2. Isn't it? Isn't it? Carbon atom number what? 2. So it's going to be 2 ol. Something, 2 ol. Isn't it? Then what about this? 1, 2, 3. 1, 2. So either way it is 2, 2. Ne? So it's also this one is going to be 2 ol. This one also is going to be 2 ol. You see that the position of the functional group is the same. But if you look at the chain, it's different. You see? The chain is different. That's why you're saying that it is a chain isomer. You understand? Well, this one is a functional isomer. The chain here has changed. You understand? But the position of OH is the same.
So from secondary to tertiary is...
Yeah, if you don't change, it can be still position depending on how many carbon atoms do you have. Yes, but in most cases, it can be a chain isomer if the position of the OH is not changed on the carbon atom which has the functional group. Yes, I saw the hand somewhere.
So the chain isomers, the names also change. How you call it? The first,
Yes.
second composition.
All of them, they change. The naming will change, but the number of carbon atoms and stuff, they remain the same. Let's name them. Let's name them. This is what? 1, 2, 3, 4. Ne? 1, 2, 3, 4. So this one is carbon atom number 1, isn't it? So it's going to be 1, 2, 3, 4. It is 4 is what? Remember, when from alcohol, we add up to here. You don't only stop here. Ne? Butane, but it's on carbon atom number 1. 1, and alcohol, we add OL. So it's going to become butane 1 ol. No, it's 1, 2, 3, 4. There are 4. Prop is 3. Yes. Now, what about this? What about this? Is it but? Yes, it's but. 1, 2, 3. 1, 2. So it's carbon atom number 2. Ne? So it's going to be 1, 2, 3, 4. It's going to be butane 2 ol. You see, the position has changed. That's why we say positional isomer. What about this now? It's going to be 1, 2, 3. I think. So it's going to be propan. It is on carbon atom number what? 1, 2, 1, 2, 1, 2. It's the same thing. So it's going to be propan 2 ol. Now let's look at the side group. So it's going to be 2, but how many carbon atoms are they? It's 1. 1 is meth. So it's going to be 2 meth, but when it's a side group, we add YL. Therefore, it becomes 2 methyl. Is it clear? 2 methyl propan 2-ol. Is it clear? Sister, you record, you note down what you should remember. We are doing this not because you don't know. No, man. Not because they didn't teach you. No, man. We're not here for that. We are here just to remind ourselves and to shorten the time of revising. You understand? Because when you do this, when you open, you remember. You watch a video, where, because you're going to be there on YouTube. Simple. So your life becomes easier for you to write the what? The paper. The paper can't kill you. You must kill the paper. Any question before? Yes. Someone is saying, this one. Guys, we need distinction, eh? Need distinction. You guys, you need distinction. You need distinction more than I do, eh? Yeah. I think we have talked about that. We have talked about all of that. I think now there are some few things we're going to talk about. Ne? Let's remind ourselves before we go to rates of reaction. Let's remind ourselves about we are done with the alcohols. Ne? Let's go to carbonyl compounds, and then we see how do we name it. Just remember, if you know how to name it, it's simple. Then we go to the esters. We look at esterification, done. Then after that, we see some few equations, and then we wind up with the properties. And then we know that organic chemistry is done. I give you a break of maybe 10 minutes just to stretch. Then we come back for rest of reaction, and then also talk about the 10 minutes just to stretch yourself. And then we come back for rest of reaction and also chemical equilibrium. Then you go home. Yes, speak. Why so early? You think we are saying it? You think that it's gonna be ending now? Hey, Wena. Hey, Rusha. You think it's gonna just end now? It's easy to say, but to present it on the board.
I'm doing everything so that we have done like everything.
Yes. Yes, it's just to. Now, let's talk about carbonyl compounds. Remember, carbonyl compounds are grouped into two, which are ketones and aldehydes. Ne? And then, ketones and aldehydes. Ketones and aldehydes. Remind me.
So we're under
What is...
we're under rates of reaction.
No. We are still on organic chemistry. Structures. Ketones and aldehydes, ne? We said that ketones, where do you find the functional group? At the end. Serious? Where? Along the what? Along the molecule, ne? So if I have CH3, CH2, CH, CH, 1, 2, no man, 1, 2, yes, CH, 2, CH3, ne? When we maximize it or we write the structure formula, it's gonna be like that, isn't it? Let's label it. Let's name it. IPAC naming. So it's gonna be 1, 2, 3, 4, 5. So it's gonna be 1, 2, 3, 4, 5. Pent. Remember, we don't stop on pent. Pen, we add AN. Ne? And then now, what is the position? 1, 2, 3. 1, 2, 3, 1, 2, 3. So the direction is equal. Ne? If it was 2 here, then it's 1, 2. 1, 2, 3. So I go with the 2. But now it is not that. It is. So it's going to be 1, 2, 1, 2, 3. How do we do the ending? Keton ends with this. 1. Is it clear? So it becomes pentane 1 on. Why 1? Because that's the ending. That's the ending.
No, why 1?
Oh, did I say 1? 1, 2, 3. It's 3, ne? Yeah, it can't. Keton can't be 1. It will never be 1. It will never what? No, the reason why I wrote 1 there. The reason why I wrote 1 there. No, maybe it was in my mind. I said 1. Yes. Keton will never ever be 1. You understand? It will never. The moment is 1, it becomes an aldehyde because it's at the end or it's at the beginning. You understand? So it starts with 2. So it's going to become pentane 3 on. Yes? Also, this is correct. Depending on your teachers. Ne? So if you say, but I want you to go with this. Ne? Yes. You can also say 3 dash pentanon is also correct. So I don't know what your teachers taught you, but this is correct. Also, this is correct. But we prefer this. I prefer this. Yeah. Is it clear? Yes. So now, well, let's convert this into a functional isomer, which is the aldehyde. Remember, aldehydes, they end with Al. You understand? They end with what? Al. So it must have that at the end. So I'm going to say, I'm going to put this at the end. Ne? So it's going to be CH3, CH2, 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 COH. Yeah. This hydrogen is attached on hydrogen. This hydrogen is attached on the carbon. So it's going to be 1, 2, 3, 4, 5. So it's going to be penta. Then I add Al, which is pentanal. We don't have position because it's always at the end. You can't say pentanal 2, pentanal 3. No, man.
So is that a CHO at the end?
It's Al.
No, that thing.
CHO. Yes. So it's pentanal. We don't have the position on the aldehyde. The same thing, we don't have a position on the carboxylic acid. Is it clear? So basically, that's how we can write this. Let's go to the carboxylic acid, because the way how we name carboxylic acids and esters is a little bit different from this. From the normal what? Normal naming. Can I rub off here? Chaka, are we together? Are you getting something? Are you wasting time here? Oh. Litabo. 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 You know when Litabo you a soldier, ne? Say when the captain say Litabo, yes sir. So I'm the captain. Litabo. You can say yes, sir. It's nice to be a soldier, ne? Yeah. They say, come hello. Yes, sir. Life is good, ne? Yeah, there is no, if all human beings were like soldiers, ne? This world would have been peaceful. Hey. I'm telling you, soldiers, they are the most disciplined organ. Yes. It's the organ of the country. Hi, you guys. Yeah, we have different organs. All right. Let's look at the carboxylic acid and what? And the what? Esters. Who is Esther? Who is called Esther here? There's no Esther here. There is a girl called Esther. Yeah. All right. Carboxylic acid is 1 CH3 CH2 CH2 COOH. Remind me, how do I end with the carboxylic acids? Oik. Not enough. It's not enough. Oik acid. Acid. It ends with what? Oik acid. Now, let's say 1, 2, 3, 4. This one does not have a position. Is it clear? It doesn't have what? A position. So it's 1, 2, 3, 4. Isn't it? So it becomes 1, 2, 3, 4. It becomes butanoic acid. Simple. Sisters, when you see double O, that is either a carboxylic acid or an ester. If it's at the end, it's a carboxylic acid. If it's at the beginning, it's a carboxylic acid. If it is along the molecule, then it's an ester. Yes?
So the oic acid is separate water.
Oic acid. Yes. Now we have. Now let's convert this into a functional isomer, which is let me separate by this: CH3, CH2, COOCH3. Isn't it? 1, 2, 3, 4. Now, yes, it's 4. 1, 2, 3, 4. Guys, don't forget about this. Let's expand it. Let's expand it. Let's expand it. Structure formula, isn't it? Now it's like that. How do you write this? Which one is the main or the mother, and which one is the side group? I told you. So I have 1, 2, 3, 1. Which one is the main chain?
Because of the oxygen.
The carbon atom which has the carbon atom which has the oxygen with the double bond, it becomes the main chain. It means that this one came from the carboxylic acid, while the other one came from the alcohol. You understand? So it means that I'm going to say 1, 2, 3. 3 is what? Oh, how does esters end? Owet, ne? Yes, they end with owet. Owet. Oic is carboxylic acid. Esters is owet. So now it's going to be 1, 2, 3, which is no. Wait. 3 ne? Not 4 ne? Okay. Wait. Ne? Now, this one is what? 1, which is meth. So it's going to become methyl. Here we don't have position. We don't have position. We don't put any figure anywhere in carboxylic acid and esters. We don't put anywhere. So it becomes methyl propanoate. Is it clear? What if you might look at it as if it is the same but it's not the same? Ne? What if it's like this? CH How do I label that? How do I name it?
So,
Which one is the main chain and which one is the side group? Let me even add another one.
so come to other side.
Huh?
So,
The main chain.
Huh?
is it possible for it to be a side group in a side group?
Huh?
Like, you see the thing that you do?
I have another side group. Yes, but not in our level now here. It's very possible. Eh? How do I? Where is the side group? I have 1, 2, 1, 2, 3.
Or run two.
On the right.
It's this one.
So, oh,
It's the side.
Look at the O.
The side. The side.
Where's the main? Where's the main chain? This is the main chain, eh? All right. Yes. Because of this, then it becomes the main chain, isn't it? And then this one becomes the side group, isn't it? All right. Now people are thinking of side chicks. So now what is? How are you going to label it or to name it? 1, 2. It's gonna be ether. No wait. But the side group 1, 2, 3. So it's gonna be 3 is what? Propyl. So it's gonna become propyl ethanoate. Is it clear? But a question can come. Which one is the functional group? Functional group of alcohol is OH, ne? Like that. What is the functional group of carboxylic acid? Carboxylic acid is OOH. C. It must have a dash, ne? COOH, ne? And then esters. C O O C H. Never. Okay, guys, if you are confused, ne? If you are confused with that, use R. Just put R there, which means that this is an alkyl group. We don't know how many carbon atoms are there after this. Ne? Yes, but this one, it must end with A. Even this one, you can put R there.
that's ester there.
You understand? Yes. This is an ester. Even this one, you can put an R there. You understand? We don't know how many carbon atoms are there.
So the first one is CSOOH. I don't see it.
Yes, COH. No, it's the same thing. It's the same thing. Ne? It's the same thing. So it's like that. Or you just write C O. Yes. So basically that's it. That's about the naming. Unless you have any question, Itabo. Unless you have any what? Have any question? If you don't have any question, you tell me, and then I continue. Life is good, ne? Life is good, ne? Life is good, guys, ne? Is life good? Who is saying life is good? Life is not good, ne? Not really, ne? You are still a student. What about when you become a father? Life is not good when you're a student. When you become a father, you will know that, hey, guys, life, yeah. If you want life to be difficult for you, be stiff in this world. Don't be flexible. Don't fit in any environment. Yeah, you'll see how life is it. But if you want to be simple, easy, if you want life to be like that, just relax. Be flexible. You understand?
Yes.
Go with the flow. Then you will see that you will see that life is going to be easier for you. Ne?
I love it.
Yes. All right. Let's just talk about, you remind me, ne? Just few reactions and the properties. Ne? Properties. Guys, in this section, I don't expect you to have anything related to a cross in your marks. In that section. Yeah, in this part, we are finished. I don't expect you. A cross where? The only thing why you get those crosses is because you are rushing. When you see the paper, you get excited. Yeah. I know this, and you know what next? If you overspeed where you're not supposed to overspeed, what happens? Accident. So you end up having accidents in your papers. You come out of the paper, hey guys, I've killed the paper. Can't the paper is what? Hey. All right. Hey. Remind me, guys. Okay, we have talked about that. Let's talk about. Okay, I think let's start with this esterification thing. Guys, remind me. What is the function of alkanes? Alkanes. What's the function? What are paraffins? What is it for?
Fire.
It's used for fuel, ne? Okay. I'm going to ask you a question, you prepare, ne? It's about polymerization. Ne? Yes, it's about... Now I'm just going to look at the different equations, ne? But I'm not going to look at all of the equations. We are just going to look at equations which are... Okay, you have what you call hydrogenation. Hydrogenation, hydration, hydrohalogenation. Yes? Those terminologies, they're under additional reactions. Ne? Those terminologies will determine what you add. If you see water is being added, then it becomes hydration. Isn't it?
Hydration?
Yes, hydration. If you see water is being removed, you form a product as water, then it becomes dehydration. You understand? If you see hydrogen is added, then it becomes hydrogenation. Hydrogenation. When you see hydrogen is being removed from the equation, then we say what? Dehydrogenation. Is it clear? What about the hydrogen halides? Hydrogen halides, like hydrochloric acid, hydrofluoric acid, hydrobromic acid.
So is it
When you add a hydrogen and a group 7 element, then it becomes hydrohalogenation. When you remove it, you see it as a product, then it becomes dehydrohalogenation. Is it clear? But note on this, please and please, make sure that you read about their conditions. Is it clear? So the only two equations I'm going to talk about, they are going to be for esterification and polymerization. Esterification and polymerization. Is it clear? But before I go there, I want you to tell me what is a saturated compound and what is an unsaturated compound, and how do we identify them in exam. What is a saturated compound? Uh-huh.
So this is a compound that only has a single bond, and an unsaturated compound is a compound that has a double bond
I wanted to say that. Your marker has gone. It was going. Yes. It must have saturated compound. These are compounds which have a single bond between the carbon atoms throughout. And then unsaturated compounds are compounds which have double bond between the what? The carbon atoms. How do I identify a saturated compound?
It's always okay.
No, man. I'm talking about between, how do I differentiate? I bring a solution here, I bring a solution here. One is a saturated compound, one is a saturated what? Unsaturated compound. How do I identify in a lab that this is a saturated compound, this is an unsaturated compound?
Saturated is thicker.
In a lab.
So we're doing it, remember, it left like something like a vaseline.
Yes, but I want to know in a lab, what did we use? Color? Uh-huh. How?
I guess one is pink, one is white.
When is pink, when is white? Hey, guys, stop it. That's only what I taught you.
Obviously, you put sulfuric acid.
Woo. That's only what I taught
Some
you.
powder, ne? You put some powder.
That's only what I taught you.
So should we use leucinizing paper?
Guys, I taught you. Now I see now. You are just guessing. I taught you that we use bromine water. When it decolonizes bromine water, it is unsaturated compound. When it doesn't decolonize bromine water, it is a saturated. Yes, it decolonizes. Remember, bromine is red. Yes? When it decolonizes bromine water, it is a saturated compound. Huh?
No, it's unsaturated.
It's unsaturated. Let me write it on the board through equations and then you see. Because now I see people, they have forgotten. It decolonizes bromine water. Yes. So they can bring an experiment and say that compound A decolonizes bromine water. Compound B does not decolonize bromine water. Which one is a saturated compound? Or which one is an alkene? Or which one is it? Based on the table they have given you. So you look at the table, you see whether it has a double bond or a triple bond somewhere. Once it has, then it means that that is unsaturated compound. Is it clear? So let's write it by equation and then we see exactly what happens. If you have, for example, CH3, CH double bond, CH3, ne? That is an alkene. Ne? Even if it is CH3, C triple bond, C, no man, CH3, ne? I add bromine water. Remember, bromine is a diatomic molecule, ne? Plus, this is a liquid, ne? This is a liquid. It's red in color. Red, ne? You understand? Now, the reaction is going to take place, and then I'm going to have, this bromine is going to split, and then one bromine is going to come here, one bromine is going to come here, and then it becomes saturated. So it's going to have CH3, CH, ne? And then a bromine, and then CH, a bromine, another bromine, and then CH. So, which kind of reaction is this? This is addition. I've added. Therefore, it becomes, what am I adding? It becomes halogenation. Because bromine is a halogen, is a group 7 element. Therefore, the reaction becomes halogenation. Is it clear?
The reaction of the product becomes
is a halogenation. The reaction is halogenation. I'm adding a halogen in the reaction. Yes. So when I expand, it's going to be hey. I see that people have forgotten something. If I put the bromine there, another bromine there. Done. So now this one is colorless. That's why you say it decoloralizes the bromine water. Is it clear? The same story this one is going to be. But now this one is going to change from a triple bond to a double bond. So that when I add more bromine, it's going to be decoloralized more. From now, from a double bond to a single bond. Colorless. Colorless.
How do you know the difference between hydrohalogenation and
Hydrohalogenation, if hydrohalogenation, if I had hydrochloric acid or bromic acid, a hydrogen and a bromine, you understand, is hydrohalogenation. But here I'm only adding bromine, or group 7 what element. Therefore it becomes halogenation. So if I'm removing, then it becomes dehalogenation. Is it clear? Yes. There's something you guys, I'm thinking you forgot it, and I need to talk about it before I go to polymerization. What is that? Mechanical fluid. Mechanical fluid. Now I didn't teach you this, Hey, life is good, ne? All right. Oh, remember we said that when you are adding a compound with a hydrogen, yes, either you're adding it usually happens to hydration and hydrohalogenation, because hydration, remember, you have this OH plus a hydrogen. These are the molecules you are adding. And the hydrohalogenation, you are adding maybe a bromine, yes, and then you're also adding a hydrogen. So these two. Markovnikov says that when you are adding these molecules, hydrogen will go to a carbon atom with a high number of hydrogen. You remember? Now you remember. Oh, I remember. Hydrogen will go, I'm going to give you an example, don't worry. Hydrogen will go to a molecule which has a high number of hydrogen. And then this one will go to a molecule, not a molecule basically, to a carbon atom which has less number of hydrogen. So hydrogen will go to a carbon atom which has more hydrogen, while this one will go to a carbon atom which has fewer hydrogen. This one. All right, let me give you an example. Can I rub off here? Huh? I had that. So
Hydrogen goes the most.
it goes where? Hydrogen will go to a carbon atom with a high number of hydrogens. You understand? Yeah, you might not understand it now for those who are not in my class, but let me give you an example. You understand it better. Now, let me think about the equation I should give you. CH3. CH. Three? It can't be. Two? Huh? It can't be. CH. Ne? CH2. I sing it? I sing it?
Oh, yeah.
I sing it?
Yeah.
Now I add, should I add bromine? Hydrobromic acid?
Use bromine.
All right. Now, now let's expand it, ne? So that we split it and then we see how does Markov talk about this.
It's marked.
The condition for
This one,
hydrogenation.
this one is just it happens. The moment you add, it's like putting food in the mouth. You don't tell the mouth, hey, chew, it knows what it's gonna do. The moment you put the food there, it's just enough. You don't need to push, hey, eat. There's no sick people here. Ne? This is not sick, ne? It's normal. Just bring a pizza, put in the mouth, enough. No, you know why I'm talking about pizzas always? It's my sons, they ask, Daddy, pizza. All right.
We're also saying pizza every day.
Yeah, you're always saying pizza every day. Hey, wait.
So you call us your saying
Pizza. Yeah, you must say that.
then will you buy it?
Yes. No, when I see Max, say, okay, guys, here is the pizza. Yeah. When I see Max, but if I don't see Max, I say, pizza where? Yeah. All right, guys. Now, look. You have this molecule, this carbon atom, and this carbon atom. This one has one carbon. One hydrogen. Well, this one has two hydrogens. I think. This one has two. This one has one. I think. Markovnikov says that this hydrogen will go to a carbon atom with the more hydrogens. So it means that when I'm writing the equation there, this one is going to obtain the third hydrogen. While the bromine is going to go to the one which has fewer number of hydrogen. Therefore, the reaction, when the reaction completes, then you're going to have CH3CH2. You see? Okay, let me draw it the way it is. CH3 here. Now see, you have the hydrogen there. Now this is gonna go here, and then I have bromine here, and then I'm gonna have CH. This is 2, and then this hydrogen is gonna come there, and then I'm gonna have CH3. So that's how it's supposed to be. If you swap them, you're gonna get a 0, because this becomes a minor product, this one becomes a major product. When you swap them, it becomes, you put this one here, it becomes a minor product. It happens in a reaction, but is a minor product. So when you are writing these organic molecules, remember, we are synthesizing. We are synthesizing maybe medicine or what. So what we are looking for is a major product. Therefore, we are looking for the major product, unless the question comes for a minor product, which is very rare. But if you are looking for a major product, even if they don't tell you whether it's a major product or a minor product, you have to use Markovnikov rule so that you get this right. Yes?
So where does the hydrogen, the double bond,
Where does the double bond what?
break? Because it was a double.
It's here. It breaks. This one comes this side. This one comes this side for the hydrogen. This one attaches the hydrogen. This one attaches the what? The bromide. And then you form. Remember, a carbon atom cannot have more than 4 bonds. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Always when you write a structure formula like this, count the number of carbon atoms. Sorry, the number of bonds on carbon atoms. They must be 4. If it is shorter than 4, you just know that your structure is wrong. Yes?
So this
Eh.
always breaks the bonds.
Yes. Yes. So this happens with this, or when you are doing hydration. Because hydration also has the carbon, it has the hydrogen and the OH. So the OH will come here and the hydrogen will go there. Is it clear? Yes. Are we done with this?
So,
I said before I go to esterification, before I go to polymerization, did I talk about esterification? Okay, let's talk about esterification, formation of esters. Ne? Because those are some of the reactions where students struggle. Do you understand? Yes, and I don't want you guys to what? To struggle. Ne? Yes. Don't want you guys to struggle.
so do you think they'll ask us to state
They-
do you think they'll ask us to state Macron's
But I've said it.
They ask us
state like
I've said it.
define- So they're gonna ask.
I've never seen it, but you have to know how to apply it. Ne? But if they ask, then you have to say it. Just say how the description. Yeah. All right. Chaka, are you okay now? Because you were not fine when I told you that come attend chemistry. Don't worry about Mr. Muhammad. Mr. Muhammad is gonna come. This is what he wants. You cannot be writing physical science on Monday. You wrote math, and then you go for math today. You understand? Yeah. Yeah, he is also a human being who wants kids to pass. You understand? Yes, you saw him, he came and said, yeah. As long as you are here, you understand? Yes. All right, guys. Let's just talk about esterification. Ester what? Ester what? Yes, son. Yes, sir. Some of you gonna be soldiers. You must be soldiers. Yeah, protect our country. Ne? Protect our country. Eh? Chaka, you don't want to be a soldier. You want to be a doctor, ne? You can be a doctor who is a soldier. Who treated you treat the soldiers who are wounded in the battlefield. You see, yeah. Number one, you are getting money, ne? A lot of money. Not only that, you are helping the people who help the country, who protect the what? The country. You can be a soldier, ne? Yeah, you can be a soldier.
Why do we have soldiers?
Huh? Why do you have soldiers? I'm sorry to say so, but if you want to know why do you have soldiers, that question will be answered by Ukrainians. Yeah, Ukrainians. You see how much they need soldiers.
They don't have soldiers.
How much they need soldiers. No, they have, but not enough.
Hey, Russia.
You understand? I don't know too much of politics, but soldiers are supposed to be there to protect the country. Guys, let's come back here. Let's come back here.
So I want to talk about this practical.
A practical Wednesday.
Yeah, I'm saying, why couldn't you just do it after 19? Because you within 2 papers right now. So I don't see why I can't do this.
Come back here, guys. Come back here, guys. Esterification. That's where esters are being formed. But during this process, you have to know exactly what is the raw material and what is the product and what are the conditions. Is it clear? Raw material, reagents which are needed, conditions, and the products. Remember, we can change whatever we change, but we end up having the same product, but the product will be corresponding with the raw material. So in esterification, what do you need? Number one, I want the reagents. You need the carbonyl. Xylic acid plus alcohol, giving you conditions. Conditions, it must be strong acid. It's not enough. No. I'm talking about the acid. That strong acid is not enough. I need to hear something. You see this acid? It's not enough still.
Plus heat.
No, I want to talk about acid. Strong acid? That statement is not enough. It won't make you to earn a tick. Concentrated. That word must be there because you have dilute and concentrated. That acid must be concentrated acid. Is it clear? Elijah, do you understand? It must be what? Concentrated acid. So, if I say sulfuric acid, it must be conc. Sulfuric acid. This sulfuric acid does not stop there. It requires heat. It requires what? Heat for the reaction to take place. Then after that, remember this esterification. It results in it's a dehydration reaction. Did you know that? Esterification is a dehydration reaction. Why am I saying that? Because you form an ester plus H2O. You see? You have formed the H2O. Therefore, it is a dehydration reaction. Is it clear? Is it clear?
So second time you form an ester plus water, it's dehydration.
The moment you form water at the end, it is dehydration. Yes. It is. The moment you form water at the end, it means that that water has been removed. You understand? Yes. So it is a dehydration reaction. So now let's have an example of a carboxylic acid, an example of an alcohol, and then you form the ester and our water there. Is it clear? Tokero, choose any carboxylic acid you want. Choose, yes. Choose any carboxylic acid you want. Any carboxylic acid.
So like we must give you
No, just tell me what I write. Just say it by name. Propanoic acid. Saying propanoic acid. CH3, CH2, COOH. Propanoic acid. Chaka, choose any alcohol you want. No, man, I want the name. I want the name. Propan to all. Why do you want to that? That is too much.
You said N.
Carbonyl, yeah.
Propan to all. Yes, we can write it. But choose a primary alcohol.
Carbonyl.
Propan 1 all. Propan 1 all. CH3, CH2, CO. The problem is, you students, you like this complex thing, complex things. When I no, man. No. They are complex for you because you didn't practice questions. I'm telling you. No, there are some things you bring whereby they can't bring for you. Not that difficult things.
Do you know what's question 9? I don't even remember.
We know. Okay, in presence of conch, sulfuric acid, and then we heat our thing. Remember, you know what we do, ne? We pour it, ne? We pour it, ne? You know what we do? You remember during the process of esterification? Yeah, when we are in the lab, ne? Yes. Now, after that, now let's see. How do we write? Remember guys, this carboxylic acid is going to lose that, while the alcohol is gonna lose the H. You understand? These two, they combine to form the water, which is there. And then now this and this, they combine to form the ester. Can I repeat?
Yes.
The carboxylic acid will always lose OH. The alcohol will only lose the hydrogen. These two. Okay, remind me. You were reminding me about the alkane, alkene, and alkyne. If I write like this, C which homologous series is that among the three? Huh? It must have another C there. Yes.
I think it's the last one.
Which one? Alkyne. Eh? Why are you saying alkyne? Guys, when you find this and you can't know it exactly, expand it. And then C, CH, because this one is CH3. You have there. Now, a bond goes here, isn't it? But here I don't have hydrogen. You see? Even the next one, I don't have hydrogen. And then the last one, I have CH and then 3 hydrogens. Are you seeing? If I have no hydrogen here, what does it mean? It means that I have to make sure that there are 4 bonds. So I have, for this one is 1, 2. So I have to add another one. 1, 2, 3. Not yet 4. I have to add another one. 1, 2, 3, 4. So 1, 2, 3, 4. You see? Now it means that the structure looks like this. Now you ask yourself, the one which has a triple bond is an alkyne. Why am I doing this? Is because of the... Sorry? Good morning, ma'am. I'm okay. So what I was saying, last time they brought this question, and I saw that many people failed this question. If the question is like this, CH3, ne? CH2, ne? CH2, 2, ne? CH3. What does it mean if it's like that? Remember, in most cases we say that when something is in the brackets, it means a branch. But it depends on whether it's a when does it become